Thank you, everyone, again for joining us today. My name is Katie Poser. I'm the outreach librarian for the NOAA Library, and we are more than happy to bring you this presentation today. So, our presentation is Taking Aim at R2O, O2R in Huntsville. So, we have a whole panel here from the Huntsville location and nearby who represent NOAA, NASA, and several programs within that. And I'm more than excited to hear them introduce themselves and get this presentation going. So I'm going to hand this over first to Brian King. I'm going to get this wrong, Brian. Carcione?
Carcione.
Carcione. I knew it. Okay, so I'm going to make sure you guys are up on the screen for everyone. And please, Brian, take it away.
All right. Well, it's a great honor to be speaking, and I'm going to. Sydney's going to be driving, so I'm going to let her start. We have multiple, as you just pointed out, we have multiple affiliations there on the screen. So to give you a little bit of background on what we're talking about here, what brings all of these different entities together in Huntsville. So my affiliation right now is I work for National Weather Service Southern Region Headquarters in Fort Worth, Texas. I'm the chief of the Science and Training Branch. But several years ago, I was the Science and Operations Officer at the Huntsville National Weather Service office. And Huntsville is one of the best places to be a science and operations officer because Huntsville has such a unique atmospheric science community. So the NOAA facility, the National Weather Service office, is located on the edge of a large research park on the campus of the University of Alabama in Huntsville. And they're in the building shown on the screen there at bottom left. And part of the reason the office was located here in 2003 when it became operational was because of the broad collaboration potential. So the office normal operations are that they issue forecasts and warnings for northern Alabama and a portion of southern Middle Tennessee. But a big part of the culture, a big part of the operations beyond the day-to-day is collaboration with the University of Alabama in Huntsville and the NASA Marshall Space Flight Center Earth Science Office. So the University of Alabama in Huntsville, you'll hear us refer to it as UAH. They have a Department of Atmospheric and Earth Science, which has been around for many years. They have a really good reputation for research in earth science, remote sensing, numerical modeling, atmospheric electricity and lightning, which is relevant to our story today, severe weather, among other things. So there's a really strong connection to National Weather Service and NOAA needs. They can help us research things to help us do our jobs better. They have a strong graduate program, and they have since developed an undergraduate program in earth science. So the local NWS office has a lot of opportunities to work with students, as we'll talk about here over the course of our slides. The office has a really strong student volunteer or unpaid internship program. And the office has worked really hard to develop classes with the university Earth and Atmospheric Science Department. So there's a basic operational forecasting class, and recently there's been an advanced level operational forecasting class. So there's really tight collaboration there. But we also have NASA Marshall Space Flight Center located in Huntsville as well. Most of the rocket and the rocket research, that sort of thing, is located on the Redstone Arsenal military installation, but the Earth Science Office is co-located in the same building. Much of it is on the same floor as the National Weather Service. And so we work a lot with the NASA Short-Term Prediction Research and Transition, or SPORT Center. And they have research scientists dedicated to transitioning NASA's Earth science assets to short-term weather operations. Again, you'll hear a little bit more about this over the course of the presentation. So the great thing about being the science and operations officer in this environment is that um, on any given day, I could take a 30 or 40-second walk and interact with experts in remote sensing, atmospheric electricity, numerical modeling, things like that, um, not just from the university and academic perspective, but also from the NASA perspective, and get a ton of expertise beyond just what we have inside NOAA. So there's a ton of collaborative research across multiple entities. And although I'm mentioning these three main government entities, there's also private sector research and operations companies in the area as well. Next slide, please, Sydney. So I also want to mention the fantastic Hauling Scholarship Program, and that's another kind of aspect to our presentation today. So if you aren't familiar with the Hauling Scholarship Program, it's a fantastic program, provides undergraduate applicants, successful applicants, with academic assistance as well as a full-time paid internship at a NOAA facility. And NOAA facilities can compete for scholars by submitting research proposals. Next slide, please. So over the course of, I believe we're almost up to 20 years of Hauling Scholarship program. So I think since then, the Huntsville office has hosted 11 Hauling Scholars, and the research has covered topics from environmental characteristics associated with severe thunderstorms, tornadoes, storms that we thought would produce severe thunderstorms and tornadoes and didn't. We had someone who talked about the economic costs associated with tornado watches. And then what is relevant to our presentation today is that we had Sydney help us out looking at geostationary lightning mapper trends associated with tornadoes. Next slide, please. And so for our office, when we put together these proposals for the Hauling Scholars to investigate, so we would put together a proposal. These are the things that we want to research. These are the things that we expect to learn. These are the things we expect you to learn. There's a very formal outline and very formal format for the proposal process. One of the sections is called expected outcomes. What's the benefit to the student? And every time we put this together, we said, this is a unique opportunity. This is a unique environment. We're co-located with NASA and UAH, and this is an opportunity for you to go beyond NOAA, go beyond the National Weather Service. So if you find that you're really interested in research, or if you find you're really interested in the topic we're talking about, there are opportunities to make connections with other entities. And that was in addition to what we might offer as a National Weather Service office. So it was a really great opportunity to add to what was already a really strong collaborative environment. So with that, I will turn it over to Kris Schultz, and he'll talk about the NASA Sport Program.
Thank you, Brian. Yeah, so Sydney, we can go to the next slide. The NASA Sport's been around since 2002. It was established as a way to get NASA data into NOAA hands. So you had MODIS at the time, you had some early lightning data sets that would precede the geostationary lightning mapper. And so NASA, the vision there was, how do we get some of these low latency data to help with decision making? One of the first products that was being used operationally within the Weather Service was some of the MODIS products, like the false color you see there that helped with snowfall. And so what evolved over time, though, is not only did we help the Weather Service with transitioning NASA data, but we also worked with different entities. So we've been around for about 20 years. We've transitioned well over 50 products. We do basic research as well. So it's not only bridging the research over to the operations, but we also develop our own products, and we'll talk about a couple of those in a couple slides. And the main thing here is just providing the support and of getting data into people's hands that are making decisions. And so our paradigm is not only the research to operations, but there's also an operations to research component, which Kris White will talk about here in a little bit. But our history is rooted in helping the National Weather Service and NOAA with decision making. The original leaders of the sport project, two-thirds of them went on to NOAA, being Bill Napenta and Steve Goodman. And Gary Jedlick, who recently retired, was the other of the trio that started it. And currently, sport is being led by Dr. Emily Lybrand. If we could go on to the next slide, Sydney, what we'll see is the sport paradigm. So our philosophy is within sport is we try to match the operational, the stakeholder, the decision maker, with an NASA data set that helps them to solve a problem. We don't show up with products and say, okay, look at this shiny new object. It's how can some of the stuff that is available help someone that has a decision to make or a challenge or something where they have a need to help inform the partners beyond their purview. And so it's really an agnostic approach where we can apply it to not only weather. We've actually started talking with the space weather community a little bit about doing this. And we've been working with private sector, DoD, and a number of different agencies across the spectrum to help transition research into operations. So if we slide into the next PowerPoint slide, we have well over 400 partners and stakeholders that span over 80 organizations. There's a few of them listed at the bottom there. And what I mean by partners, it's somebody that we can physically talk to on a day-to-day basis if there's a challenge or if we need feedback, if as we're developing new products or transitioning products, really need some honest feedback to help translate the needs back to the scientists and the developers so that they can improve their products. We're trying to eliminate the previous way of doing science where a scientist works on something for a very long time and then they get to the end of their development and say, here you go. And then the stakeholder goes, yeah, that's great, but I need it in these 4 other ways that help me make the decision. So really what our philosophy is helping co-develop along the way so that the stakeholder, the decision maker has input to the science being done and the scientists and the developers have an idea of what the actual need is, since you can have multiple different decisions being made off of a single data set. We do everything from weather modeling to drought to pre-fire, primarily with lightning-initiated wildfire. Big push recently with Tempo and air quality forecasts. As Tempo is the new NASA mission that just launched earlier this year, and it's becoming operational. And then we've also worked with marine hazards and a little bit with not only NOAA, but also the disasters program, FEMA, National Guard, and trying to respond to different events as they occur. So if we slide to the next slide, a couple of the recent products that are being heavily used within our purview, the sea surface temperature product, which is now global. It's at a 2 kilometer resolution. It's being used by a number of different individuals, not only within NOAA, but also within the private sector. We've got at least 4 or 5 different private sector companies that are ingesting these data on a day-to-day basis. And we find new ones as well, because we aren't an operational entity. We try to do our best to make the data available as quickly and low latency as possible. But if something breaks, we don't have an operational mandate, so we get to it when the next available time is for our data production team to be able to get it back online. But this is how we find out that we have more users than we know about. And so sea surface temperature is one that's being heavily used right now, especially with Debbie raging in the southeast United States, producing a lot of flooding, is our machine learning streamflow forecasts, where this is actually one of the cool O2R type of things, because the Huntsville office was using our land information system, which is a soil moisture data set that allows them to see how dry or wet soils are. And then they use the QPE forecast from the GFS and kind of eyeball, well, if we know this amount of soil moisture and this amount of rainfall, we're going to flood. So what we did within sport is we took the feedback from the Huntsville office, we developed a prototype, tested it, and now we're in a number of different river forecast offices, as well as individual river forecast centers and individual offices, trying to provide content beyond 48 hours, because that was the need. Most of the forecasts were only going out 2 days. We can now give them a little bit of a glimpse out into the future, especially bigger long-term events like Debbie's, it looks like it's going to be. And then with the lightning theme that Brian was talking about, we've been doing lightning at Marshall Space Flight Center since 1979. And so one of the things that we've been developing is not only the technical capabilities and the instruments, but the applications and how to use these data. How do we inform the public? And so one of the things that I've been leading is called Lightning AI. It's a NASA-based approach. We're supporting our emergency managers at each NASA center. And so what we do is we use machine learning to predict lightning in the next 15 to 20 minutes on the cadence of electrification and helping proactively predict when lightning will next occur. And so that way we're not being reactive. Thunder roars, go indoors is a great slogan. I'm on the National Lightning Safety Council. But what we need sometimes is to be a little bit proactive in the approach of, hey, lightning's coming, because you've got a number of different decision support events that have large crowds or have to have multi-steps in the chain of decision making. And so Lightning AI's vision here for now is to support the NASA centers and anywhere that's close enough to any of the 11 NASA centers. But ultimately, we're working a little bit with private sector now to hopefully get it into people's phones and it be more accessible via cell phones so that people can make decisions on their own, and also it's more readily available for those that are in the field. So these are a couple of our recent developments. We continue to work in research in a number of different ways as well. But for now, I'm going to turn it over to Kris White, who's going to talk a little bit about our unique position, the applications integration meteorologist, which means he's half National Weather Service forecaster, half sport decision, just helping us making decisions, developing products, and getting feedback from the field. So Kris, turn it over to you.
Okay, hey, thanks a lot, Kris. I appreciate that. And so yes, that's my title, Applications Integration Meteorologist. I know it's a mouthful. It takes me a while to spell it out myself or say it when someone asks me what's my title. But anyway, so what am I? I've got a few slides here to talk about this and just some of the projects I've been involved with that sport, and then how I met Sydney, and largely through some of these sorts of efforts, and then I'll let her talk. But so I am actually a National Weather Service employee, but I am jointly funded by sport, and as was mentioned just a little bit ago, we are co-located here in my office. We're in the National Space Science and Technology Center building on the campus of University of Alabama, Huntsville. And very conveniently, sport is just right down the hall. So I think, as Brian said, it takes us maybe 20, 30 seconds, whatever, to just walk down the hall and be there with the researchers at sport, attend meetings and that sort of thing. So, but I am stationed here at the Huntsville WFO, as said, but I'm not intended just for WFO Huntsville. In fact, the great majority of my time is spent actually working with people and other offices, and to some extent even other research institutions and other product developers outside and even inside of NOAA. So you can go to the next slide. So I do have to kind of be a person that wears a lot of hats. I do that the best I can. It can be difficult at times, especially as any of you who are in the Weather Service know, this is a very dynamic, a changing agency, and a lot of things have changed over the years that I've been in this role. It goes all the way back to 2011. It's hard for me to believe I've been in this role that long. And incidentally, I don't remember if Brian mentioned it, but he was my predecessor in this position before I got into the role. But anyway, I do try to wear all these hats as best I can. Even an IT officer, there are some products that I have, created config files for to get them working in AWIPS. Includes a number of different products and even some more things I've got coming down the pike I've got to work on. I'm not going to go into a lot of detail here just in the interest of time. But also, yes, I am a senior forecaster. Usually when I'm on shift, I'm the FIC, although a lot of times I'm used to fill in shifts because I'm not in the regular rotation, and so. But I do work similar to a Sue in a way. About 15 to 20% of my time is spent working on forecast shifts, and that's so I keep in touch with operations, and I also get to use some of the products that sport develops and test them myself in the real-time operational environment, which can be interesting. And so, but I think that's a little bit of an advantage. And I do serve as, a sport, technical, scientific data product, sort of an expert when I am on shift or just when I'm here in operations or elsewhere. And so with that, in some way, you might say I kind of act as a Sue at times where I am supposed to have that expertise and provide leadership with regards to sport decisions and helping to advise them from an operational standpoint. So I am kind of the advisor in a way to the research side of the house, and that's of course the sports side, and also help develop training materials and that sort of thing. And so yes, as you see in the bottom left corner, the liaison. So yes, I do provide that insider operational perspective to the research community or to the research side, especially in sport. And communicate results of product transitions, and we'll conduct assessments about these products and what is working, what's not, what might need to be modified, and that sort of thing. And I get to go out and do office visits, which is really interesting, and sometimes sit and just literally shadow forecasters or other workers at different offices around the country. I've been everywhere from Alaska down to Florida and a number of points in between. And just recently, actually, got to visit what's called the Southern Area Coordination Center to learn about some of their challenges with wildland firefighting, positioning of assets, and all that sort of thing in the Southeast. And also visit the Southeast River Forecast Center. So you can go to the next slide. So, some people have asked me, what is my job like? And I came up with this little set of cartoonish, I guess, slides here, these next few. But, I guess in a way, I am really kind of situated at the nexus of the R2O, O2R process. And so some of the conversations, this is how it might go, just in a very basic sense. But, the researcher may say, hey, take a look at my new product that I've developed. And sometimes I might have a question that says, well, how am I supposed to use this? Sometimes there may not always be an intended application. Most of the time there is, but sometimes we'll try to discover that application together. And sometimes I might say, hey, here is what we need coming from me back to the research side. And they may come back to me and say, well, this is what is possible at this time. And so they have to work within their own constraints for, people, time, money, resources, and all that sort of thing. And sometimes that's one thing that maybe the operations side doesn't get too well about the research side. But I try to help bridge that and kind of relay that to operational folks as best I can. And then sometimes the researcher may say, hey, here is how you use this product. And I'll say, on our side, we might say, okay, here's some feedback about it. Here's something you might want to know about it, what's working, what's not. And maybe I also found another use that wasn't intended. And that's certainly something that does happen in this product development process where it goes back and forth between research and operations. And I have at least one or maybe more stories about that in the next few slides. So you can go to the next one there. So back in I'd be remiss if I didn't talk a little bit about some of the projects I've been involved with through the years, and Brian was involved with some of these as well. This goes back to the early part of the GOES-R and JPSS proving ground days, and the advent of satellite RGBs, and really more so here with the GOES-R era than what we had previously. And so, for example, one of the things that I was doing, and Brian also was doing back when he was my predecessor in this position, I was trying to get forecasters ready for some of the new satellite capabilities that were coming with the new era of GOES-R, and also with the JPSS proving grounds, and now that we have NOAA 2021 up there. So one of the things is that this is just an example of this is colorized sort of fog product imagery. But we were going to have new imagery from RGB, something like the nighttime microphysics RGB, which really made it a little bit easier to see fog and distinguish low clouds from other sorts of clouds. And so if you go to the next slide there, here you'll see this transition of what that was like. And so in the early days, we were getting these swaths from polar orbiters, actually, from MODIS and Aqua satellite, the MODIS instrument on the Terra and Aqua satellites, and also the VIRS instrument subsequent to that. But you can see a lot more detail. And so we were helping to transition these to other offices and getting forecasters there prepared for what was coming with the advent of much more enhanced capabilities with the satellite imagery from the GOES-R series, like you see here. And so I was very involved with that, some years ago. And if you go to the next slide. And then one of the bits of feedback, of course, we got is that, well, it can be a really difficult thing to get forecasters, especially in the CONUS, to look at polar orbiting satellite imagery. Forecasters in much higher latitudes and places like Alaska are certainly more prone to doing that sort of thing, and they're used to that. But to get forecasters in the CONUS to kind of consider these and at least look at them, if nothing else, just from a training standpoint about what is coming, could be a challenging thing. And so one of the things from the feedback that Sport then did was just to insert polar orbiting imagery into the geostationary imagery that was available at the time, and do it in an intelligent way such that the new type of RGB that was coming matched some sort of existing sort of satellite imagery. And here you see just an example of that I had saved some years ago. One of these old examples was the air mass RGB inserted into water vapor imagery. And so getting forecasters ready for this new type of imagery that was coming was something that we were very deeply involved with. And so you can go to the next slide. And so, Kris, a little bit ago, touched on the Sport Land Information System. Now, originally, this was actually developed to provide near real-time land surface data for local WRF modeling efforts, and we had some of those efforts at my own office, and there were some other offices with which Sport collaborated with closely in these sorts of efforts. But around the time that Brian was in my job here and then I came on, I have some other focal point hats I wear in my office, and I'm also the climate and drought focal point in addition to another one or two. And when I found out about this high resolution data set, this soil moisture data set, I said, well, this is very intriguing. I want to learn more about this. It's something we could use for drought analysis. And so at the time, it was much different. They only had really a southeast CONUS domain. But over time and through some use of the data set and communication of the value of this data set, there was expansion of it to include the full CONUS as you see here. And there are even some OCONUS locations now where we run this, including it's run in Puerto Rico and the U.S. Virgin Islands and up in Alaska. We've had other requests for Hawaii and some places like that. We haven't got around to that yet. But through some other efforts, they're even doing some of this internationally now. But what you see here, actually, these two examples that I have in this slide are soil moisture percentiles. And then you notice there's a lower one that's a 1 week change. And this came about through the use of these data very specifically for U.S. drought monitor and drought analysis. And I said, this is not only feedback from myself, but from other users of the data, that if we were going to use them, especially for drought applications, we needed this context of climatology. And so percentiles were very important because that's, typically a standard that's used for the drought monitors. They're looking at soil moisture percentiles. And then the changes were important and useful because the drought monitor, for example, it's updated weekly. And I said, it'd be really useful if we had weekly changes, and perhaps changes on other sorts of time scales too could be interesting and useful to look at, especially for these drought analyses. And so this is, one story about working with Sport, but then Sport interacting with the operational end user community, and then making changes to data sets based on feedback from users, and not just myself, but other users all around the country. And a lot of that was funneled back through some of these assessment efforts that I conducted with others in the Sport program. And actually, I do have a link here. There's a lot more about the Sport Land Information System at the NASA RSET training site. And I have a link here, so if you want to screen capture that, you can do that. And you can go to the next slide. I probably have to speed it up here. So, oh yeah, and so this kind of segues into this project here. And as Kris mentioned a little bit ago, I won't go too deep into this, but not only were we using the land information system data to assess drought, to help assess that, but also its opposite, on the flooding side. And we'd come up with some sort of crude methodology for assessing, increased risk for flooding based on soil moisture levels. But, we had some conversations about this at Sport, and I said, it'd be great if we had something a little more mathematically robust. Was wondering if we could go down the road of some of these machine learning approaches, and eventually they agreed to do so and had the people and time resources to do so, and computational resources. And so we went down this path. Originally, it was just a few offices, and we very early on in this whole process, when we were just modeling a few streams and seeing how it worked out, reached out to the development operations site. I think that's the term, hydrologist, and that's Dave Welch at the LMRFC, and reached out to him. He came on board as a collaborator in this project, and then since then it's expanded quite significantly. And we're actually about to add even more dots to this map, but I think we're somewhere in the vicinity of about 250 gauges now, and working with a number of WFOs and RFCs across the country, where we are producing streamflow forecasts using artificial intelligence. And we're incorporating a number of different QPFs across each of these basins, and we still have some more development work and some more QPFs to add into all this. And so this has been a really interesting project that really grew out of the use of the LIS for flooding, but now we have this pretty robust and pretty engaging project here, where we're doing stream flow forecasting using AI across a lot of locations here. So you can go to the next slide. And there we go. Okay, so now this will help me segue here finally into Sydney. So one of the big efforts, and this was touched upon, I think by both Brian and Kris too, was the use of LMA data. And you see that here in the upper left. That's actually total lightning data from the North Alabama Lightning Mapping Array. And if I'm not mistaken, this was actually a severe weather event. I think this was March 2nd, 2012, when I was on radar that day, issuing warnings and using the data, and actually assessing whether or not lightning jumps were occurring in this particular case, which did actually help to assist in warning decision on that day. Eventually, these data were meant as a proxy for what was coming with the GOES-R era and the geostationary lightning mapper instrument, which you see an example of that in the on the upper right there, but that's just below the associated radar imagery. Now, I will say we did not have these two data sets in operations at the same time. We had the LMA. It was removed. It was sent, from what I understand, down to South America for a field validation and testing campaign for when the GLM came on board, and it was covering, of course, the whole Western Hemisphere. But we had already gotten used to the application and to the concept of total lightning data and using it essentially for jumps. But not only that, you typically see flashes within cloud before you see cloud to ground, and so that gave us a little bit of a heads up just over the basic cloud to ground networks and early lightning warnings for airport weather applications and that sort of thing. And that also led to other projects, as you see here. So lightning forecasting, as Kris mentioned, with the lightning AI. And actually, by the way, that is turned back on, so we need to get with our collaborators about that. That was very recent. But it was also some of this work here when we brought Sydney Lybrand on board, and I believe that was in the summer of 2019, if I remember correctly. And she had a project where she was working on lightning jump algorithms, and so she met me, and I had some expertise in this, and so did Brian. We worked with her, but we have limited expertise, and so we had someone down the hall like Kris, who we also brought into the loop because he could help field some of the more difficult questions that maybe we weren't able to answer. And so, and then I'll just segue now into Sydney. So thanks.
So First of all, my name is Sydney, and I'm a hydrometeorologist with IBSS, and I support the NOAA National Weather Service Office of Water Prediction and their Atlas 15 program. So I really like all of atmospheric science and weather, and I like to learn how it impacts us on a day-to-day basis. So I really like helping people and learning how new things work, and then helping other people to learn those things also. So we're going to time travel sort of back to 2018 and sort of the things that were going on in my life then. So in 2018, I was a student in Northeast Alabama Community College, which is a community college in Rainsville, Alabama. And I was getting ready to transfer to UAH in the fall. And I knew that they had a good atmospheric science program. So I had started looking into things that could potentially help me alleviate some of the financial burden that college would be. So I started looking into scholarships online, and I found that there were actually several scholarships for people with interest in meteorology. So one of those was from NOAA. And at that time in my life, I knew that I wanted to work with the Weather Service. That was my dream job. But I didn't know what NOAA was. So I looked into what NOAA was, and I realized that it was a really cool organization, and there were a lot of great things that NOAA done for people within weather, oceans, the whole 9 yards. So I realized that the organization was really neat. The scholarship was the Hauling Scholarship, and it looked like something that would be a great opportunity for anyone who's in it. So in early January of 2018, I put together an application and I submitted it. So fast forward a few months, and I am at a point in my life where I'm about to graduate Northeast and transfer to UAH. And so I went down just sitting at the computer doing my history homework, and then I get an email, and it's from the Hollins people, and they offered me an appointment, which was just wild. I would have never in a million years ever guessed that. So I was extremely shocked by that, and so then I accepted it. Then I graduated Northeast, and then I went to the orientation at NOAA headquarters so that you get to see all the cool things about NOAA. You get to go and, do a tour of a NOAA facility, and they just tell you all the great things of what NOAA does. And then back in the fall, I came back to Alabama, and I began the process of transferring to UAH. So after I transferred to UAH, I started thinking about the internship and all the things that I could do with that. And I started looking around at places I could go and things I could do. And one of the things that I thought was if I were able to stay in Huntsville, then I would be able to meet people within the building that I wouldn't necessarily know and just have a lot more potential opportunities, it felt like. So I knew that I would like to stay in Huntsville if I could. And then I finally found out the people that I needed to talk to there in Huntsville to find out about potential internship opportunities. So that was Brian Carcione, and he was the SU at that time. So I went and I talked with him, and we talked about a couple different project ideas. And the one that really stood out to me was the project on the GLM data, because it was really new and they hadn't really worked with it a whole lot. So it seemed very interesting to me to be able to work with a product that was new and upcoming and something that I could help contribute. So I started my internship during the summer of 2019. And one thing that I learned during that was not necessarily just about meteorology, but just about myself in general. I learned that I wasn't really interested as much in the forecaster route as I had originally thought. And I learned that something more on the research side of things would be more close to what I was interested in. So I started pursuing more of the research path instead of the forecaster operational route. And the internship went really well, and it allowed me to meet a lot of people both in the office and there in the building. And one of those was Kris, who's the application integration meteorologist. And he helped me a little bit with the lightning jump stuff. And so I had a couple of questions, and he said to read a paper. So I read the paper. Well, then he said, hey, we've got this person coming by this afternoon. He's going to sort of talk to you about this stuff. So I was like, okay. So he comes, and I was like, this is not just anybody. This is the person I was just reading about. So I was reading Dr. Schultz's paper in the morning, and by the afternoon, he came by and he talked with me, which is just wild. I was so surprised because I'd never thought that it would work out like that. So in the evening, Dr. Schultz came by, and he helped me a lot to understand how the lightning jump algorithms worked. And so then over the rest of that summer, I worked on that internship research. So it was all on the geostationary lightning mapper data. There had been jumps identified in ground-based sensors, and so we were just wanting to see if that worked in the GLM data as well. So after meeting Dr. Schultz, then I was able to understand more about NASA sport as a whole, and it was a really cool organization. They do really great things. And so I finally finished up the internship. I went back to the NOAA headquarters to present my research. And then that fall, after I came back, I was able to start with sport as a student. And I was also able to stay on with the National Weather Service Huntsville office as a volunteer. And then enter 2020. So in 2020, in the beginning of 2020, I stayed on in the student position in the spring, and I was able to continue working as a volunteer with the Weather Service, and I was taking all these really great, cool classes. So I'm like, just loving it, right? Because I'm getting to do all this cool stuff for my work. I'm getting to do all this cool stuff in my classes. It's just the best. And then everything goes online. So I started going to school online. I started doing my research position online. And then the Hollins program comes to an end. So in 2020, it's a little bit of a low point there. So then I finally graduated with my bachelor's in December. And I was able to wrap up my undergraduate research. And that was on GLM also, but it was the GLM infrared RGB product. And then I was able to start a GRA with sport in January of 2021. So that GLMIR product is basically just a product where you use GLM combined with other satellite data to help identify a cloud's current convective state, whether it's decaying, intense, or growing. And so in 2021, I had a complete roundabout change. I'm starting graduate school, and it's all online, and I'm starting a GRA, and it's all online. But I'm extremely grateful for the GRA because I learned so much about myself, what I really am most passionate about, what I enjoy about the weather and about researching the weather. And over that year, we were able to slowly be able to go back on campus a few days a week, and then some form of semi-normal had started by then. So I continued on in graduate school for 2022, and then in late fall of 2022, I started thinking about what was going to happen to me after school. So I finished all of my classes at the end of 2022, but I still needed to defend my thesis and graduate. So I started looking into some potential job opportunities, and I was eventually offered one at UAH in a full-time research associate position, and it was with NASA Impact, which is a different portion of the Earth Sciences branch of NASA. So I started there in January of 2023. And over the course of the next few months, I was able to defend my thesis and then graduate. And then the day after I graduated, my thesis was about these two specific cases where we had very similar forecasts but very different outcomes. One day I had a lot of lightning initiated wildfire, but one didn't. And so I hypothesized that aerosol within the atmosphere changed the thunderstorm characteristics, which changed the potential for lightning. So they were a really cool project with a whole bunch of interesting data and outcomes. So the day after I graduated, I started looking into more jobs that were more closely aligned to what I enjoyed. So I applied for 3 jobs that night, and one of those jobs that I applied for was with IBSS as a hydrometeorologist, and I got it. So on July the 28th of last year, I left UAH, and then the following Monday, I started as my hydrometeorologist position on the Atlas 15 program. So what I do now is just a whole bunch of really cool historical data. So maybe it's flooding, snow. It could be even things similar like the Northern Lights, or maybe they're talking about halos around the moon. So like in the Iowa example from 1941. So it's a little bit of history, and every now and then it's a little bit mystery because it may be hard to read, or it may be, just curious to understand what the weather was like then. But the really cool thing about historical weather data is it's one way that we can connect with people from the past, because we couldn't be there, but we can understand what the weather was like there. And so all of our data is going to be included in the first ever nationally consistent precipitation frequency data set. So from all of the past experience that I had with the Hollings program, sport, then back to NOAA again, I think that me being able to support NOAA now after them supporting me for so long is a great full circle experience, because through all these different interactions, I've been able to learn what I enjoy most. So it's more of that transformative, traditional, or applied type of research, and not really forecasting or operational meteorology. I've also been able to work with really cool people who do really cool things, and have learned a whole lot from them. And I've also been able to have a much more eventful and exciting career, and I would have never been able to think that was possible. So I'm going to be extremely grateful for all the people all the way through that have helped me get to where I'm at, because they've seen things in me that I don't really see in myself. But they're really, really helpful, and I've really learned a lot. And at the end of the day, I can just summarize it by saying that really the greatest lesson that I've learned in my life is I still really have a whole lot to learn, but I like it. I want to continue to learn.
Thank you so much, Sydney, and everyone, for that amazing presentation. We're going to flip now to some questions and answers. So if you had a question about any part of the presentation today for any of the panelists, please place that in the question panel. And I'm going to ask everyone to turn their cameras on, and for Sydney to stop sharing the screen so we can get everybody back here on screen. Okay, we've got everyone back. Awesome. I'm going to check the question panel. I'm not seeing anything yet. So I just want to, again, thank Sydney for kind of tying it together at the end, why we have all of these great panelists today. But my question is going to be, is there anything that for any of our panelists, if there was anything that you didn't get to say that you would like to say now? Got a lot of thinking faces.
Well, I would just say it's I often don't have a whole lot of time to, unfortunately, but what little bit time I may have, it's really rewarding to get to have all these students come through here and talk to them about a little bit about the history of some of the products that they're seeing. Which I've been in the field long enough, I guess I could say some of the history of it. And but then talk to them about really interesting things that are coming down the pipeline, and some new satellite capabilities and assets that are up there now, but ones that will be coming down the pike, and that they'll, provided they get in the field, that they'll get the experience to utilize. And so I didn't really mention all that, but Sydney was one of those students, and I'm glad to see that our efforts helped her. But she was, I remember her. She was a very hard worker and very diligent, and just kept moving along on her analysis. I do remember being impressed by that. So.
Thanks, Kris. Kind of to that point about students coming through, be it through the Holling Scholarship or other internship opportunities, and Brian saying that this was kind of a unique thing to Huntsville. I'm going to ask, is it something that is is there opportunities across the country for similar types of work with either the Weather Service or the Weather Service NASA combined, or is it just kind of Huntsville?
So I can speak to that a little bit, hopefully. So I can speak to that a little bit. the Hollings program is open to any NOAA office. So if you're at a NOAA office and you have a question you'd like to help answer, you can put together one of these Hollings proposals. And again, that's you're kind of trying to make your experience, your research project appealing to one of these outstanding students like Sydney. Um, and it's just about the relationships, and it's just about finding the right match. Sometimes you may find someone who might work out well, and maybe once they hear more about it, it's not exactly what they're looking for. So it's just kind of a matter of finding the right match for what you need and what the student is looking for. Um, I think a lot of offices around the country have pathways positions, which are paid internships that can transition into a full-time position. And then, as I mentioned, there were unpaid internships, certainly at most National Weather Service offices. And I believe the National Weather Service homepage has links to some of those opportunities just across the country. Now, how many offices have this unique co-location of NASA and university and NOAA? Not many, and I think Huntsville may be the only one with that particular combination. But we're hopefully maximizing our opportunities to collaborate across the board. This one just may be that a particularly unique set of collaborations.
And I'll add on to that, we have an intern program within NASA too, and we work with the Weather Service, especially in Huntsville, to get our intern over, especially this summer, we were testing out a new lightning product, and we had her go out on one of the decision support events to see what decisions were being made. So it's part of that integration that we've got in the community that's really helping bridge the gap between research and operations. And I believe also we've got a sport researcher who's working on her master's, who's also volunteering at the Huntsville office right now too. So it's kind of one of those things where it is kind of one of a kind, where the opportunities are abundant here in Huntsville. Just like other places have pairings between NOAA and university and NASA and university. Just we happen to have all three of them right in the same place.
And with all three of them in the same place, what is the next exciting thing that's going on that you guys can talk about?
Kris, do you want to take this one, or do you want me? Which perspective do you want, Katie?
Hey, I'm looking for all sides of this. We've got a whole 5 minutes or less if you guys don't want to go that deep.
Right. So from the NASA perspective, we're really pushing the new Tempo satellite, which is in partnership with NOAA. It's a NASA mission, but NOAA is heavily involved, and it's doing hourly air quality from geostationary orbit. It's kind of in its testing phase right now. The data are being developed. The products should be streaming by next spring, but we'll be able to map every hour and sometimes even sub-hourly different constituents, aerosols, PM 2.5. And so now you can combine the mapping of those constituents with the ground sensors, and now you can get a more holistic point of view of air quality, both at the surface, and also look at cool things like lightning knocks, which is how nitrous oxides are being produced by lightning when they occur when you pair with the geostationary lightning mapper data. So from the research side, that's what we're super excited about in sport, is getting that air quality data out to end users like the Weather Service, like other parts of NOAA, to help in those decision making and be on the forefront of new satellite generation as well as product development.
Thanks, Kris. I think we may have lost our other Kris. I'm not seeing him pop on anymore, so we might. Oh no, maybe he's here. Kris White, do you have any NOAA side to the exciting things happening?
Yeah.
There you are. You're back. Perhaps. We may have lost you again. That is A-okay. If we can't get Kris back, that's okay. Maybe it's a sign that it is time to wrap up and give everybody a few minutes back in their day. So I want to thank everyone for attending today. Thank our panelists again for a great presentation, and Sydney for bringing this to the library so we could hear all about the unique work being done between NOAA, NASA, and the university in Huntsville. Thank you, everybody. I hope you have a wonderful, safe rest of your day. Stay cool out there. It is a hot one.